Hi friends, today we will continue our topic of Lewis structures, and this time we will discuss the violation of octet rule. So, exceptions of octet rule. Indeed, there are three cases when we can make an exception for octet rule, when octet rule is violated. So, three cases. Let's consider each of the three cases. The first case, here we had the odd number of valence electrons cannot divide it by 2. The second case is when we have too few valence electrons. So it means that there are not enough electrons to complete the octet. We don't have enough electrons, so in this case we will get less than 8 electrons. The third case, where we have too many valence electrons. Now let's consider each of these cases. So let's consider these cases. So exception 1. As we said, we have an odd number of valence electrons. For example, we take NO, nitrogen monoxide. If we calculate the number of valence electrons, it will be 5 for nitrogen because it's in the 5th group. Oxygen is in the 6th group, so we take 6. We have 11 valence electrons. Or if we need to calculate the number of pairs, we can write it in this way. We see that we cannot divide it by 2. Like 2 electrons make a 1 pair. In this case, we can say we have 5 pairs and 1 single electron. Let's draw the skeleton and complete the octet. So we know that valence of oxygen cannot be 1. We put one more line here. Valence electrons. Let's see. And we should have 5 pairs. Here we have 1, 2, 3, 4. Only 4 pairs. 5 pairs, only 4 pairs. So one more pair can be put on nitrogen. 5 pairs. And 1 single electron. We can write it on nitrogen. In this case, we see that around oxygen we have 4 pairs, so we have 8 electrons. So octet rule is full, but around nitrogen we have 1, 2, 3. 3 pairs means 6 electrons and 1 single electron. So overall we have 7 electrons around nitrogen. We cannot draw 8 electrons around nitrogen because the number of electrons is odd. Let me show you one more thing. What if we draw it in this way? What if we draw 2 pairs on nitrogen, 1 pair on oxygen, and 1 single electron? In this case, we can say that it's not possible. Why? Because oxygen is more electronegative. That's why, first of all, we put all the pairs on oxygen. When octet of oxygen is completed, after that, we pay attention on nitrogen. So first of all, electrons will go on oxygen. Moreover, if we calculate formal charges here for nitrogen, for this one, take number of valence electrons minus number of bonds, 1, 2. 2 bonds minus number of single electrons, free electrons, 2 here, 1 here, so overall 3. We get 0. It's 0, it's good. Formal charge for oxygen, for this one. So number of valence electrons is 6. Minus 2 bonds and 4 free electrons, it's 0. So in this case, we see that in both the cases, formal charges are 0. Let's find formal charge for the second nitrogen, for this one. So number of valence electrons, 5. Minus number of bonds is 2. Minus number of free electrons, 2 pairs, it means 4 electrons. We have minus 1. Formal charge of oxygen will be 6 minus 2 bonds and minus 3 free electrons. It will be plus 1. So we get 1 plus on oxygen. First of all, we will compare these two molecules. With this, that the first one is more stable. we should try to get such a molecule when the number of formal charge is the minimum. In the first case, we have no formal charges. In the second case, we have 2 formal charges. Of course, the first molecule is more stable. Moreover, we should pay attention on one more thing. Oxygen is more electronegative. It cannot have a positive charge, while the less electronegative element has a negative charge. When we write formal charge and we see that it's not possible to draw the molecule without a formal charge, there will be anyway a formal charge, we should pay attention that a negative charge will be on that atom which is more electronegative. In our case, oxygen is more electronegative than nitrogen, but it has a positive charge. It's not correct. So we say that this molecule is more stable, NO. And as we can see, this nitrogen, for this nitrogen, octet rule is not considered, it's not followed, because the number of electrons is odd. And let's now consider the second exception. Exception 2. We said that for the second case, there was when the number of valence electrons is too few, not enough electrons. For example, let's take boron H3. Let's find the number of valence electrons. Boron is in the 3rd group of the periodic table of elements. So group 3, it means it has 3 valence electrons. Plus hydrogen is in the 1st group, it has only 1 valence electrons, but we have 3 hydrogen atoms, so we multiply it by 3. We get 6 valence electrons, right? Or we can write 3 pairs. Okay, let's try to draw its Lewis structure. Boron, H, H, H. We draw the skeleton. We have 3 pairs. We should have 3 pairs, and we have 3 pairs. 1, 2, 3. We have 3 pairs here. Octet rule considers having 4 pairs around it. For boron, we see that there are only 3 pairs. 3 pairs, so 6 electrons. We cannot add one more pair, lone pair on boron like this, because in this case we would get 4 pairs. But we see that we have 3 pairs only. So there should be only 3 pairs. So it's correct. What happens? On boron, we have 1 empty orbital. So there is 1 orbital for 1 pair, for an electronic pair. We draw it like a square. This is also an exception. It's a violation of octet rule. So this rule is also called incomplete octets. Let's now review the exception 3. In the case of exception 3, we said when there are too many electrons. So we can say expanded octet. For instance, let's take this molecule P chlorine 5. Let's find the number of valence electrons. For phosphorus, it is 5, it's in the 5th group. For chlorine, it's 7. We have 5 chlorines, so 7 times 5. We have 40 electrons, or 20 pairs. We need to add 3 more electron pairs on chlorine to get 4 pairs for each chlorine. To follow the octet rule, we see that every chlorine has around it 4 electronic pairs. Let's find it. We need to have 20 pairs. Let's count them, like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. The number of pairs is considered. It's okay. But let's check the octet rule. Let's take phosphorus, and we see that it has 1, 2, 3, 4, 5. Phosphorus has 5 pairs around it. 5 pairs means 10 electrons. Octet rule is violated here. So we don't have the octet rule. Octet rule considers only 8 electrons around an atom, but here we have 10 electrons. How is it possible? Indeed, it is possible, but for not all the elements. This is for the elements of the third period, which have an empty 3d orbital. You will write 3d0. This d subshell, which has empty orbitals, is considered to be free to accept more electrons. That's why we don't consider only 3s2, 3p6 and overall 8. But we also consider 3d0, which is also empty and can take more electrons and create bondings, more bondings and more electronic pairs. So it has an empty 3d orbital. This is why elements of the third period, which have an empty 3d orbital, actual 3d subshell with orbitals, can have more than 8 electrons around it. So more than 8. Octet rule is not followed. In this case, we call it, here for phosphorus, we have expanded octet. We have too many electrons, but there is also an empty 3d subshell, and we get more than 8 electrons around one of the atoms. It's called expanded octet. So this case is also possible. These are exercises for practice. You can practice yourself and ask your questions if you have. See you in the next videos. Good luck.